Hi everyone. Pre-calculus 1-6, function operations and the composition of functions. Okay, you will have to deal with the domain in this chapter. So let's do review on previous chapter about domain. So question is, find the domain of this. Um, so if you have a graphing calculator available, you could graph this using graphing calculator, which will be something like this. And just looking for the domain, how far to the left graph reaches, how far to the right graph reaches. You can see from -3 to 3. So if you have graphing calculator available, this wouldn't be that bad. So domain will be -3 to 3, solid, solid, you're done. Okay, many case, I'm not gonna provide you graphing calculator and I'll ask you to find the domain. And you have to do that without graphing calculator. So then how do you do that? So let me go over that process. So domain, there are two styles of domain questions. First style is a rational function, denominator cannot equal to 0. This is the second style, square root. So how do you solve the domain problem with the square root? Inside the square root cannot be negative. So inside the square root, you let that greater than equal to 0. And you're solving for x. So here, I like to write descending order of the power of x. So I like to write like this, x squared minus x squared plus 9 greater than equal to 0. I don't like having leading coefficient as a minus. So I'm going to multiply by -1 everywhere. So I'm going to multiply by -1 here. I'm going to multiply by -1 on both sides. When you multiply by minus, make sure you flip the inequality. So you have to do this. X squared minus 9, 0 times whatever becomes 0. So your question becomes solving this inequality. How do you solve that? I will show you two different ways. One way, factor this first. So you got x squared minus 9. Minus 9. 9 is exactly the same as 3 squared. Then you get to use the formula. So you need to memorize this formula. A squared minus b squared formula is a plus b parenthesis a minus b. That's the formula. So applying that, x becomes a, 3 becomes b. You can apply that formula, x plus 3 times x minus 3 less than equal to 0. How do you solve this? So one way to do that is you get these zeros first. So let x plus 3 equal to 0, x minus 3 equal to 0, solve for x equal to minus 3, x equal to 3. So you got two zeros. So on a number line, you got minus 3 here, 3 here. So basically, you divided the entire number line into 1, 2, 3 different intervals. And you're seeing which interval will satisfy this inequality. So you pick a sample number from each interval. You can pick -4 here. Plug it in -4. So -4 plus 3 -4 minus 3, you're checking, is that less than equal to 0? So that's what, -1 times -7 less than equal to 0. That's a positive 7, less than equal to, you're questioning, is that less than equal to 0? 7 is not less than equal to 0. So that is not the interval we want. You pick another sample point here. So let's say 0 is between -3 and 3. You plug it in 0 there. So 0 plus 3, 0 minus 3, you're questioning, is that less than equal to 0? That's a 3 times -3, which is -9, less than equal to 0. Yes. What does that mean? We are taking this interval right here between, that is what we are taking here. you do have to check this interval. So pick a sample number as like 4. Plug it in 4 to this inequality here. So it'll be 4 plus 3, 4 minus 3 less than or equal to 0. 7 times 1 less than or equal to 0. 7 is less. We are questioning, is that true? No. What does that mean? We're not taking this interval. Be careful with equal sign, no equal sign. It has equal sign, so you have to include endpoints. Include endpoints. One of the ways you actually plug it in minus 3, it becomes 0. 0 equal to 0 works. You plug in 3 for x, it becomes 0. 0 equal to 0, so that does satisfy. That's another way to do it. If you have an equal sign, make it solid. No equal sign, make it empty. So we got the domain, which is minus 3, comma 3, bracket. Or in interval notation, that's interval notation, or in inequality, you could have answered like this. Okay, my preference when you deal with this is the following. So that's one way. My preference, rather than doing all this work, I like to graph right here. I like to graph. So I got two x values here. So I got x as minus 3 and positive 3. And you look at this, coefficient of x squared is positive. That means I have a parabola open up. And it has passed these zeros. And I'm looking for y value. This left-hand side of function value is less than or equal to 0. Y is less than or equal to 0. Meaning, you are looking for a portion of the graph below x-axis, which is this. So I'm looking for this portion where is graph under the x-axis. Minus 3 to 3, minus 3 to 3. Equal sign, you want to include the endpoints. So for me, this is faster. It depending on you. If you are familiar with the sketching graph quickly like that, this is going to be easier. But another way is this. Okay. So that's how you do the domain. That was a review which you will need for this chapter. Composition, we'll talk about function operations and the composition of the function. Okay, operations with the functions. So let's say there are f and g, two different functions. We can do sum, product, difference, quotient of two functions. Very straightforward. F plus g of x is exactly same as this notation. What do? Add two functions. F minus g of x, what do? We just subtract functions. F times g is you're multiplying those two functions. Okay, be careful. This time notification here, notation is solid dot. There is another notation coming with a dot, but that's empty dot, which is a composition. So solid dot means a product. Quotient is f divided by g, f over g. Denominator cannot equal to 0. Very straightforward. So given f of x is following, g of x is following, h of x is following, find the function and the domain for f plus g. So f plus g, very simple. What do? Where f? Where's f? F is right here. Plus g. Where's the g? Just plug it in here. F plus g. Plug it in f, plug it in g, and that's it. F is what? X squared minus 2x. G. G is what? 3x minus 4. Okay? And in front of a parenthesis, there's nothing there. So it's distributing 1, which doesn't do much. In front of parentheses, there's nothing there, which is 1. Distributing doesn't do much. Combine like term here. So minus 2 plus 3 makes a plus 1. Final answer. Domain. They're asking you to find the domain. Do you remember? We just went over domain. There are two styles of domain question we can ask. Square root, rational function. X on the denominator. Doesn't have any of those. What does that mean? Odd real number. This is a parabola. Okay? So unless you see square root or x on the denominator, most likely it will be odd real number. For any polynomial, it's odd real number. So domain should be odd real number. I think for the RLX, you will have to answer as interval notation. So minus infinity to infinity will be a domain. Okay, so F, G, and H. Now we are looking for F minus H of X. So very similar. F minus H of X is equal to F minus H. Please set up with a parenthesis, especially minus, because otherwise you might get wrong answer. F is what? X squared minus 2x minus H. H is what? Minus 2x squared plus 1. So parenthesis here, super important because of this minus. There's nothing in front of first parenthesis distributing 1, which doesn't do much. But distributing this minus 1 here, it will change sign. Distributing minus 1 here, so be careful with the minus there. Combine like term here. That is the answer. Domain, all real number. I don't see root. I don't see x on denominator. Domain should be all real number, or minus infinity to infinity will be your final answer. C. We are looking for product f dot g. That's a multiplication. Solid dot is multiplication. So right here, f dot g. So you have multiplying. So f times g, parenthesis, parenthesis. This one you're foiling, multiply, multiply. You're foiling. So if you do this times this, that should be 3x cubic. X squared times minus 4, minus 4x squared. Minus 2x times 3x, minus 6x squared. Minus 2x minus 4 multiplied plus 8x. And you're combining like term minus 4x squared minus 6x squared minus 10x squared. Everything else doesn't change. So that's the answer. Domain is again all real number, which is minus infinity to infinity. Quotient, h over f. Put h on the numerator. Excuse me. Put f on the denominator. Excuse me. So as a function, that's it. H on the top, f on the bottom. What's the domain? What domain? Do you remember? Domain had two different styles. One style is rational function, which is this, x on the denominator. So how do you find the domain? This is a review from previous chapter, by the way. Denominator cannot equal to 0. That's how you solve a domain question. So x squared minus 2x cannot equal to 0. You have to factor. So there's a common factor of x here. Factor x out cannot equal to 0. So that gives you x cannot equal to 0. X minus 2 cannot equal to 0. Solve for x. X cannot equal to 2. So as a domain, this is a perfect answer. I think for RLX, you are asked to express using interval notation. So here's a 0, here's a 2. cannot be 0, cannot be 2. Anything else is okay. So you can go forever to the left. You can go between 0 and 2. You can go greater than 2. You can pretty much covering everywhere except these 2 points. How do we express that using interval notation? So we have a 1, 2, 3 different intervals to express as an answer. So first interval, what's the most left you can go? Minus infinity. What's the most right you can go? 0. So minus infinity, comma 0, parenthesis, parenthesis. This interval, middle one, start from the 0 left and it ends at 2 to the right. So 0, comma 2, parenthesis, parenthesis, union, union. Third interval, start from the 2 forever to the right. So 2, comma infinity, that is the domain. Of course, this is a lot simpler, but when you are forced to answer in interval notation, you need to answer this as a domain. Okay, so